Okay, this is MDE 61. It's a support course co-requisite with Math 161. Everybody, I think on my roster is enrolled in Math 61. Am I right? 161. And I think more than half the class is enrolled in my section, so you get to stay in here. Although you are invited to go out and take a break between classes. Okay. What we do in this course, it seems to have worked pretty well, is we do the same stuff you're going to be doing in your Math 161. Now that presents a little bit of a problem at the beginning of the semester because this course is starting at the same time that Math 161 is. And this means that you're going to have a homework assignment almost every day for the next, up through the next weekend. Okay. So you're going to have to work a little harder in this course at the beginning, but it should give you a good start in the Math 161. Okay. Now, of course, if you're understanding everything in the Math 161, then it'll be very easy for you to do these assignments. Okay. Or if you do these assignments before you do the 161, it'll be easy for you to do the 161 assignments because they're fairly similar. In this course, we're doing maybe 60% of a 161 to give you the idea before you start struggling with it in 161. So we hustle at the beginning to get a little bit ahead of the 161 so that by the time you've seen a topic in the Math 161, you'll already understand something of it so that you'll understand more of what you see in class and you'll have an easier time with the homework. This class is pass-fail. There are two ways to pass the class. One way is to pass the tests. There'll be tests. Another way is to pass your Math 161. To do the assignments in this course. One, but I recommend that you start by doing these assignments until you're sure you're on your feet, and then you can make decisions about which assignments you want to do and which ones you don't. If you're having trouble with a topic in Math 161, let us know, we'll try to address it. That makes sense? So don't just say, well, I know I'm going to pass Math 161. Only about 30 to 40% of the people who start 161 are successful. And it's because people sign themselves up for a course that they're not ready for. Okay. We're not allowed to placement test. Forbidden by the system to placement test. So people just sign themselves up for whatever they think they can pass. People tend to have an overly optimistic idea of what they know. Okay. People think they know more than they do. There's a tendency, not everybody, but there's a tendency among people to do that. So we get a lot of people in Math 161 that just aren't ready for it. And they should be in here. Most of the class should be in here. Most of the 161 students should be here. If they were, we'd have to enlarge the room. Okay, well, we'd have to open new sections. So one thing, you made a good decision to be here. Okay. There should be more people. And there's one person who's had, for good reasons, a student I know who I had in other classes, can't be here for about the first month, healing up an injury. That person's watching by Zoom. If you can't make class, email me before class, and I'll try to get you the Zoom link. Okay, now you're better off here, because if you're here, I can look over your shoulder as you're doing stuff and give you pointers. Okay. Small class, it's easy to do that. I give you plenty of individual attention. I don't have your syllabus ready for you. It needs to be truncated. I didn't have access to my office over the weekend. That was my excuse yesterday. I could theoretically have done it yesterday, but I'll make it a point to get all that for you by next time. You have been on Canvas, I assume, and read the syllabus as you were instructed. If you haven't, do that. Okay. Now, is everybody, how many of you have enrolled in open math? Okay. If you haven't, read the instructions. It's easy, right? Instructions are very easy. If you haven't done it, do it. If you read the instructions and do everything you can to follow them and can't do it, then email me or come and ask me. Okay. But very seldom do we have any problems with those instructions. If you have trouble finding the introduction to my open math assignment, it means you haven't read what you see on the first page. There are the first three headings. One is a welcome announcement. One is the introduction to my open math, and one just tells you a little bit about the assignments. Okay. We'll have an assignment. We're going to go over some math today regarding exponents, which is a real important idea that people tend to get confused on. People tend not to remember it well. It's been a while since you've had a math course. There's a very simple way to remember the rules. So we're going to talk about that. So again, be graded on tests. You can pass this course by passing tests in this course. So even if you fail Math 161, you can pass this course. Okay. Probably the best way to pass this course is just be sure you pass Math 161. But if you find yourself overwhelmed by Math 161, I suggest that you continue in this course, try to learn as much as you can so that when you try Math 161 again, if that is the case, you're going to be much better prepared. All that makes sense? Okay, very good. I'm going to pause the video. Another thing is, don't want you to talk while the video is being recorded. That's a privacy law thing. It's stupid as heck. I could say it's stronger than that. On the other hand, privacy laws are somewhat important. Okay. So we have to live with it. I'd prefer everybody talking, complete pandemonium and people learning stuff. Okay. It's not the way I would prefer to teach the class and have the class conducted, but I do want to have these videos available for distance students and for in-class students. Okay. They can be a valuable resource, especially if the distance students do what I recommend. And if you're a distance student, let me talk to you for a minute. What I recommend that you do is view the videos and do exactly what the videos say to do, because you'll see it here in just a little while. I'm going to give you a question. I'm going to ask you to work it out. I'm going to pause the video, circulate around, see how people are doing, comment on it. When the video pauses, stop the video and do what I said. See how you do. Okay. It's not the only way to pass a distance course. You can use the materials. There are plenty of materials in the My Open Math site. If you can learn it from those materials, sometimes those materials are a little bit flawed. Not often and not too seriously, but they do a few little bonehead things that they really should have known better than. The open math, any instructor can create videos and post them on open math. Okay. And for the most part, they're pretty good. I don't particularly like the format, but you might. Apparently, a lot of people like the format. Most people, I think. On a typical homework assignment, you might have 12, 15 problems to do. Okay. I've designed the assignments so that the first few problems are generally accompanied by video. If you don't need the video, don't bother watching it. But if you need the video, it'll help you get through the first few problems. Then later problems use the similar ideas. You want to get to where you can do those without having to look at the videos, without having to open the textbook, although if you have to, do it. Or incidentally, I mentioned textbook. You do have an online textbook there. It's right embedded. Every assignment has a link to the text section. Okay. And there's a recommended text, it's a text that I use for Math 161. I think most of the other instructors also use it. It's the OpenStax text. I think you see that information in the syllabus. Okay. It is very simple. It's a free online text. You can download it as a PDF, or you can use it sort of interactively. You can also get a copy of it for about $50, which is cheap for a textbook. I'm tempted to have it as a required text, except I'm not sure that our online textbook store can handle that. And I don't want to require everybody to buy a textbook that most people aren't going to use because they're going to do it with the online stuff. Okay. So, I kind of go back and forth on whether I want to require that. But I don't. You can also, if there's a particular section of the OpenStax text that you like or a chapter, you can go to the library and print it out. Perfectly legitimate. Now, my number one caveat in this course is don't let AI do your problems for you. Don't use published solutions on the internet and represent them as yours. Okay? If you do, you'll get your full homework credit, but your homework credit doesn't amount to that much. I mean, you want to do it, it's like 5% of your grade. And if you're 5% below passing, you're not going to pass, right? So you might want that 5%. If you use AI, if you do anything, if you let somebody else do your homework, you're going to get that 5%, but you're probably not going to get much else. Unless you're getting a lot of stuff out of the pre-calculus class and you don't really need to have done the homework in this class. Okay, it's up to you. But I will say, whatever you do, don't let AI or online resources do the homework in your Math 161 class. It's almost guaranteed failure, unless you got an IQ around 160, okay? And the thing is, and I'm speaking both to in-class and distance students. In my distance classes, I think 60 or 70% of the people are using AI or something like that because they're making perfect homework and making 12% on the tests. There might be other test anxiety. I don't think test anxiety is that severe, although maybe there are cases. I've been at 60% of my students. I don't think so. Okay. It's why I say it's a pattern that I can identify. I don't have to ask people, are you doing this? I'm almost sure that's what they're doing. The point is, they're getting perfect homework and they can't do the same thing on their tests. Okay. Another thing about this class, you'll have homework assignment for next time. And when you come in, I'm going to give you a quiz on it. And that quiz is going to be 10% of your grade. Okay. You're going to see that pretty much every day. I want to see if you can do what you do in the homework. And I see students sitting here in class, not in this class, but I see students in my classes who have perfect homework and can't do the first thing in the quiz. Can't even understand a problem that's identical to the problem they had for homework. Okay. So there's something going wrong with the way students tend to think. So don't fall into that. Okay. Everybody seems to think it's okay to cheat. If you use AI, you're not going to be able to use it in the test and you're going to fail the course. So you're cheating yourself. Okay. Now, I'm talking to many people who wouldn't do that in the first place. But as I say, I think a majority of students will. Okay. If you're in the, remember, maybe it's 50-50. Okay. So that's just the way it is. Don't set yourself up for failure. Do the work and do it honestly. Do the work in such a way that you can come in and pass a quiz on the same thing. And of course, if I see that you didn't do well in the homework and you don't do well in the quiz, once I see your work, gives me a pretty good idea what you need to hear, and we're going to address that. Make sense? And of course, you can always ask me questions. But one thing about asking questions, Open Math allows you to submit questions. And that's kind of okay, it's kind of convenient. But I actually kind of prefer email. Okay. And I think there's also something in the instructions you've been reading. It says, don't email me from Canvas. Canvas email's a mess. If I send out an email, I can't locate it later. If I want to sort it and see the emails that you sent me, I can't do it. Okay. So I don't want to get stuff from Canvas email. Now, if I do, it's okay. I'll just kind of remind you that, hey, yeah, use my ECCS address. Okay. And that's published. It's right there in your syllabus and everything. Okay, well, and I guess one more thing. I will often ask you on many assignments to send me a copy of your work. Okay. Now, if you've got a smartphone, which almost everybody does, it's real easy to do that. And it's real easy to put it in a PDF. And that's really what I want to see. Now, if you don't have the option to put it in a PDF, they're scanner ops. They all give you the option to put it in PDF. If you happen to prefer to send me JPEGs, that's okay, but don't send me 15 JPEGs. Put the JPEGs all into one file. And that's easy to do. And if you don't know how to do that and you want to do JPEGs, I can't tell you on your particular smartphone how that would be done. But I can email my students and say, hey, somebody tell me how you do that. Okay. Make sense? Also, if you email me, it won't be necessary after a week, but remind me what course you're in. Okay. Because right now I don't know your names. We'll take care of that soon. Okay. So we're going to actually start doing some math. And I'm going to pause, see if there are any questions. And if you're questioning, if you're going to Zoom and have a question, just type it in. I see the comment section here. Okay, most people have problems with at least some of these. So let's see, what does 5 squared times 5 to the 5th mean? Well, first of all, let's just let you answer a couple of questions. I'm going to pose a question, then I'm going to pause so you can answer. I'm going to ask the question before I pause. Okay, so the question is, what does 5 squared mean? Okay, so I asked the question, what's 5 squared mean? And I quickly got an answer. Well, it means 5 times 5. Okay, so what does 5 to the 5th mean? Well, I got an answer, 5 times itself 5 times. Well, just to be clear, I'm going to say 5 times 5 times 5 times 5 times 5. And I said already to the class, it was 5 to the 793rd power. You wouldn't want to have to say it all. You'd say 5 multiplied by itself 723 times, which is a little ambiguous, but everybody kind of understands it. Okay, so we can say 5 squared times 5 to the 5th means 5 squared, that's 5 times 5, right? 5 to the 5th is 5 times 5 times 5 times 5 times 5. Okay? And that equals 5 to what power? Write the answer down on your paper. Just to make sure you're getting it. Okay, now most people are seeing the answer at this point, so I'm going to erase that question mark. And I'm going to say, well, I've got parentheses here and parentheses here, but it's all multiplication. There's a multiplication between here and here. So I can write this as 5 times 5 times 5 times 5 times 5 times 5. Is that right? There are 2 of them here and there are 5 of them here. Okay. Now, what power of 5 is that? Can you show me with your fingers? Most of you are showing me. You understand this. You've seen if you've had the prerequisite courses, but you haven't retained it. Okay? And that happens. I don't know how long it's been since you had the math course. Okay? But we want to learn this in a way that we can retain it because we use it again and again and again throughout the course. Okay? And exponents are very important. Okay? So, how could we write 5 squared to the 5th? Well, we know that 5 squared is 5 times 5, right? So we could say that's 5 times 5 to the 5th. Five times 5, 5 times, right? All multiplied. Now, if we remove the parentheses, okay? And that is 5 to what power? Can you show me with your fingers? What power of 5 is this? How many 5s are there? 10. So it's 5 to the 10th. Okay. Now, to reason this out, we can write 5 to the 7th times 5 to the 5th equals 5 to the what? Well, 5 squared is going to have 2 5s, and 5 to the 5th is going to have 5 of them, right? So it's going to be 2 plus 5. If there are 2 of them here and 5 of them here, there are 2 plus 5 here, and 2 plus 5 is 7. Okay, so it's 5 to the 2 plus 5. So in general, five to the a, well, no. We'll go 5 to the x multiplied by 5 to the y is 5 to the x plus y. Okay, that's a rule. Now, if you're taught this is the rule and nobody explains to you why the rule is, or if they say this is the rule and you don't understand the explanation of why the rule is, then you're going to have a hard time with that rule. Or if it's been a few years since you had it and it's kind of gotten away from you. Okay, but there it is, and you need to understand that throughout the course. It'll come up many times. Okay, now didn't mean to put a here's a general, the most general rule. For any number, a to the x multiplied by a to the y is a to the x plus y. Okay. Now over here, what's 5 to the second to the 5th? Well, if we write it out, we get 2 5s 5 times, right? How many 5s is that? Well, everybody showed me before, that's 10, right? How do you get 10? Well, what do you have here? You have 5 sets of 2. If you got 2 things in each set and 5 sets, you got 2 times 5 sets. So the arithmetic of that is 2 to the second to the 5th is 5 to the 5 times 10. I'm going to write 2 times 5 because we did the 2 kind of first. We debated about that and then made the wrong decision. Anyhow, that's 5 to the 10th. So you don't have to write it out like this, but you should always visualize it. If I tell you 5 to the 4th to the 36th power, you can imagine 5 to the 4th, 4 5s in a group. And then you can kind of imagine 36 of those. Yeah, I don't know how good your imagination is with imagining 36 or something, but it's going to be a lot of them, right? And you know, you got 36 groups and each group has this many in it, so you got to multiply. That's why you multiply exponents. So your rule is A to the X to the Y is A to the X times Y. Don't just try to memorize the rule and hope you remember it. Understand why the rule is what it is and be able to figure it out every time you use it. Because these two rules can be very confusing. This looks a whole lot like this. And I remember I was most of the time the top math student in my high school. I had to keep reminding myself. Okay, the rules look so much the same.
That's why I'm reaching the signs.
You keep reminding yourself. Now, the easiest way to write the rules and the easiest way to remember it is probably 2 squared cubed equals 2 times 2 multiplied by 2 times 2 multiplied by 2 times 2. It's board flopping around there, so I'm not getting a good. Equals 2 to the 2 times 3, which is 2 to the 6th. Because you got 3 groups of 2 2s, right? And in contrast, 2 to the 3rd, 2 to the 2nd, times 2 to the 3rd, 2 times 2, 2 times 2 times 2, which is 2 to the 2 plus 3. And it's obvious if you write this out why you have to add them. 2 to the 5th. Okay? Make sure you're completely good with these rules. Okay, well, this 3 to the negative 2nd. Pause for a second. Okay. What's 2 to the 1st power? Show me with your fingers. 2. Everybody knows that means it's 1, 2, right? And 2 to the 2nd is 4. 2 to the 3rd is 8. 2 to the 4th is 16. Okay, because every time you multiply by another 2, you're going to double the number. Everybody okay with that? Well, by this pattern, then as you go down the list, each number is half as big as the one before it, right? And in all that pandemonium, is walking back and forth, and the camera decided to go completely out of focus. See if this helps. Sometimes it does, sometimes it doesn't. But now if I trick it just a little bit, there it is. But now I hit one level of zoom and it zoomed twice. Come on. Just changed. It is a really good camera. Except that it doesn't have a manual focus where I can set it and not have it. It needs better artificial intelligence. If it had it, it might I don't know if it would or not. Okay, anyhow, let's try again. Okay, if I go down one more level to 2 to the 0, that's obviously the next power 2, right? And what would the next one be? 2 to what power? -1, right? Okay. Well, every time I gotta go half. So half of 2 is 1. And that's kind of important because people want to write 2 to the 0 equals 0. That would really mess up the sequence here, right? It would really mess up the whole foundation of mathematics. Okay. Okay, so 2 to the -1 should be what then? Well, what's half of 1? Well, that's 1/2. And what's half of 1/2? That's 1/4. And half of that is 1/8. And we can go on forever. Okay. Now, what's 1/2? I could write that as 1 over 2 to the 1. 1/4 is 1 over 2 to the 2nd. 1/8 is 1 over 2 to the 3rd. Okay. So now my question is, what should my rule be? If a is a number, what is a to the -x? Now, this is a big jump to get to this rule, okay? So I want to see if anybody could make that jump, but not surprisingly, didn't see anybody that made it, but maybe didn't give everybody enough time. But let's say 2 to the -n equals what? And look at these 3 lines here. See if you can write me down a rule for 2 to the -n. Okay, well, what's 2 to the -n? Well, let's look. If you look at these 3 lines, 2 to the -1 equals what? Not 1/2, it's 1 over 2 to the 1. I mean, it is 1/2, but let's just skip the numbers here and look at the powers. What's 2 to the -2? It's 1 over 2 squared. What's 2 to the -3? It's 1 over 2 to the 3. So 2 to the -n is 1 over 2 to the n. That's a very important rule. It'll come up in my class, I think, before it comes up in other classes. But most things in my class will come up after they come up with other classes, as those who are in my class are going to see. Because in my class, we're just going to draw pictures. Okay. So it'll be a couple of weeks before I see a lot of the stuff that you're doing for homework in here. All right. Anyhow, there it is. Okay, well, there are 3 basic rules of exponents. Okay. And another one is any number raised to the 0 power is 1. It's not 0. So you want to really get those 4 rules in your head. And I'll write out the other 2. And again, when you see 2 powers like this, you say, okay, well, that'd just be a string of x of these and a string of y of these, which would give me x plus y. And it's right. Whatever number of these you have, whatever number of these you add those numbers, and that's how many you're going to have when you multiply. A to the x to the y equals a to the xy. then you do things with them and you simplify expressions and so forth. And open math is going to give you plenty of help with that. So I'm not going to get too far into that because I wanted to be sure that we're showing you why the rules work. Because if you focus on why things are the way they are, you're just going to understand them much better than if you just imitate what you see. Now, often you start out by just imitating, here's an example. Okay, I don't know what in the world that means, but in this example, they did this. I think you ought to do this. Try to go as deep as you can to the reason and the principles behind it. Okay. You'll see more of that as we go on. All right. Okay. Let's try. That's a z. Z squared cubed multiplied by z to the fourth. Let's see what you get using these rules. Okay, well, most of you are writing this out the long way by writing out all the z's. Now, since we have small exponents here, 2, 3, 4, we can actually do that. But what we want to do is use these rules that summarize. But I'm going to do it the way everybody seems to be doing it. You're going to have 2 squared cubed is different ways I can write this. I'm going to write it this way. So z squared cubed could be written as z times z times z times z times z times z, but I'm going to write it out as z squared times z squared times z squared. And then I'm going to write it out as z times z multiplied by z times z multiplied by z times z multiplied by z times z times z times z. And then I can just count the z's. Of course, we can remove the parentheses. But that's going to be 6 of them here and 4 of them here. That's going to be z to the 10th, right? Okay. Now, the way you're going to need to learn to do it, because the exponents aren't always 2, 3, and 4. Okay. The first thing we would do is simplify z squared to the third. Now, which rule would we use? First, second, third, or fourth? Show me with your fingers. Which rule applies to z squared cubed? Okay, anybody else? Yeah. It's the second rule. It's a power of a power, right? It's a power of a raised to a power. So z squared cubed is z to the 2 times 3. Okay, can you read that? I need to write it bigger. And then that's multiplied by z to the 4th. Well, what does that equal? 2 times 3. What's the easiest thing to simplify here? 2 times 3, that's 6, right? So we do z to the 6th times z to the 4th. So we didn't need a rule to multiply 2 times 3. We know arithmetic. Well, now, which rule do we use? First, second, third, or fourth? Which rule applies to this one? Okay, it's the first rule. We have z to a power times z to a power. Okay, it's not a anymore, but whatever the symbol is here. If it's the same symbol here with the exponents, we're going to add the exponents as the rule says. And we understand why. So that's z to the 6 plus 4, which is z to the 10th. Okay. Now let me write down another one. Let's try they might have a hard time reading exponents. That's p to the 7th multiplied by p to the 5th raised to the 9th power. And it's kind of off the screen. But there it is. Okay, some people still having trouble with this, so let's identify which of the 4 rules will apply here. Which of the 4 rules can you use? Okay, if you say it in the first rule, you can't say that because you don't have p to a power times p to another power. You have p to a power times p to a power raised to a power, right? So the first rule is not going to apply here. Okay, can you do something with the second rule? Yeah, you can apply the second rule to this part. Okay, and that's exactly what we did here. Remember, we applied the second rule to this. Now I threw a little bit of a curveball at you by writing the power of a power second rather than first. Okay, but you understand? Do you understand why you can't apply the first rule? It's not p to this times p to that. You got to get it down to p to this times p to that. Well, p to the 5th to the 9th. Okay, by the second rule, p to the 5th to the 9th, you're going to multiply the exponents. And you're going to end up with p to the 7th times p to the 45th. Now you can apply rule 1. Okay, so you have to look for something in an expression where the rules actually apply.
Okay.
And well, let's write out the details. It's p to the 7 plus 45 equals p to the 52. Okay. Let's do r to the 7th times r to the negative 3rd. Yeah, I will comment that I run this class by the clock on the wall. Okay. Now, if I find out that the other clocks on campus are on time, I'll modify that. Okay, because we don't want to mess up your schedule. Okay, r to the 7 times r to the negative 3rd is r to the 7 plus negative 3, which is same as just r to the 7 minus 3, which is r to the 4th. You want to write out as many steps as you can. Your thinking is what you do. All right. Now, there would be another way to do this. Okay, you wrote r to the -3 is 1 over r to the third. And then what's r to the 7th over r to the third? Well, that's r to the 4th. Makes sense? Throw you a loop. If you don't know what f. So if you don't know that, you're just not, either gonna have to figure it out or just not get that problem, ask a question on it, okay? We'll be covering that very soon. The other thing I say is, as I said, don't let AI do your homework for you. But if you want AI to explain the rules of exponents to you, okay? You just type, you prompt it, say, hey, I'm really rushed in my algebra. And I'm really not understanding the rules for exponents very well. Can you help me? That makes sense? That's an appropriate use of AI, and in many cases, AI can do an excellent job of that. It'll explain it differently than I have. It'll explain it differently than your book has. If you have 2 or 3 different explanations, sometimes it's like having 2 eyes or 3 eyes. Nobody has 3 eyes, okay? Okay, it's like binocular vision. You have some depth perception. Okay, think of that analogy. Anyhow, it is time to go. So go ahead and take a 9-minute break if you're in my class. And otherwise go on to the whatever you do next.